Okay, so this question's in 3D as well. This is question 18. So we're looking at two particles A and B. It says they move in a straight line, and at time t their positions relative to a point 0 are given by the following equations. You've got xa, which tells us the position of the particle A, and xb, which tells us the position of the particle B. So it says here, find the times at which their positions are the same, and give this position measured in centimetres, with distances measured in centimetres and time in seconds. So what we're going to need to do here is find when the positions are the same. That will be when xa equals xb, because those are the positions. X is a position for particle A and particle B. So those are the positions are the same. So if we do that, you can see xa, I'm just doing a substitution. So we've got 0.5 sine t equals 0.25 t squared plus 0.05 t. Okay, and what we can do, because it's got decimals, we can solve that using your TI. Okay, so, oops, I'm just going to go to my CAS and just type that in. So I've got, let's get rid of that. So we've got solve, and the expression we had was 0.5 sine t. And you can use t here or x, it doesn't really matter. 0.25 t squared and 0.05 t. We're solving that for t. Okay, so if we push enter, see what we get. We get two values here for t. We get t equals 0 or t equals 1.289. Okay, now these are times. So if we write down, we can round this to 1.29. So 0 and 1.29. So if we go back, you can write down our answers for t. T equals 0 or t equals 1.29. These are times, and these are in seconds. To get the actual position, we need to sub the time, t, into the expressions for xa and the expression for xb, because they're the actual position vectors, positions for these particles. So what we're going to do, substitute in. So we've got for t equals 0, just going to put 0 in, so we're going to have xa would be at 0.5 sine t, and t is 0. The sine of 0 is 0, so that would be 0. And xb would be, here we've got 0.25. Now looking at this, you can see t squared is going to be 0, and 0.05 t, well, that t will be 0 as well. Okay, and that just leaves you with 0. So the first position, the distance, is going to be 0. Okay, that's the distance from the origin, because this is its position as a position relative to a point O. And for the other point, we've got t equals 1.29. So we can get xa, which gives us 0.5 sine of 1.29. I'm just going to use the calculator here. So 0.5 sine 1.29. And make sure that your calculator is set to radians. So if you want to check it, remember you can go home, just check your settings, document settings. Yep, it's radians, that's all good. Return to your current. Press enter. So 0.48 I've got for there. 0.48. And it says here that the distances are measured in centimetres. So these are actually seconds, because the times are in seconds. And our position for particle B, put that 1.29 into the expression for B. So 1.29 goes there. And if I put that in now, we're going to have 1.29, 0.25, 1.29 squared plus 0.05, 1.29. And we get 0.48, and that makes sense because this is sort of a double check here of whether or not you've got your workings right. So 0.48 in both, because remember this is the position where the two things are equal, where the positions are the same. So we actually have two places where that happens. So, and I'll just put this over here, positions are the same. at, and we've got the 2, so we've got t equals 0 seconds, and it is 0 centimetres, and also, just move all that up, put that a bit too low, and also, and t equals 1.29 seconds and 0.48 centimetres. So 2 solutions for that equation, just using your CADs for a lot of it because you've got decimal points, and these are approximate. Okay, so finding positions, remember to find the times first in this one because everything's in terms of t, and then once you've found the times, these x's here, the expressions for x, give us the actual distance from the origin as a position in space.